Imagine carrying around an extra 3 pounds of life. Not your life exactly, but trillions upon trillions of microscopic tenants living inside your gut. This isn't just some quirky biological fact. This bustling inner metropolis, your gut microbiome, is profoundly shaping your mood, your immunity, and, incredibly, how you age. We're realizing that the changes happening here aren't just side effects of getting older. They might be writing central chapters in the story of aging itself, holding powerful clues to living longer, healthier lives. It's almost sci-fi. We can now estimate your biological age, albeit roughly, just by looking at the microbial signature in a stool sample. Forget crystal balls. The future of health prediction might literally be unfolding inside us. As the years pass, a familiar pattern often emerges within this personal microbial world. We tend to see a decline in the beneficial bacteria, the ones that absolutely love fermenting the fiber from our plant foods. At the same time, there's often a rise in microbes that are experts at breaking down protein, sometimes leaving behind less desirable byproducts like ammonia. This isn't just a neutral exchange program. This shift is strongly linked to something called increased gut permeability. Maybe you've heard the term leaky gut. When this vital barrier weakens, bits of bacterium like endotoxins can sneak into our bloodstream. This sparks a low-grade chronic inflammation that just simmers away throughout the body. It's led to a really compelling idea. Maybe this age-related microbial shift isn't just accompanying aging, but actively driving many parts of it, contributing significantly to frailty, disease vulnerability, and perhaps even shortening lives. But the story gets even more fascinating when we look at the true outliers, the centenarians, people thriving past 100. Their gut microbiomes often seem to operate on a different clock, defying the typical aging trends. In fact, the microbial differences between someone aged 80 and someone aged 100 can be even starker than those between a young adult and an 80-year-old. Consider the long-lived residents of Bama County, China. Their centenarians show an amazing ability to maintain vigorous fiber fermentation, churning out impressive amounts of beneficial compounds called short-chain fatty acids, or SCFAs, compared to their neighbors, who were merely in their 80s or 90s. These 100-year-olds produced more than double the amount of butyrate. Butyrate is a genuine superstar SCFA, celebrated for its powerful anti-inflammatory effects, its role in feeding colon cells, and its critical job in keeping that gut barrier strong. These centenarians also had significantly lower levels of the undesirable byproducts from protein breakdown. The message echoes louder and louder. A diet packed with fiber fueling the butyrate factory looks like a tangible path towards exceptional longevity. And this isn't just a local phenomenon. Across diverse centenarian groups, from China to Italy, we see shared microbial characteristics. One potential signature is a dramatic enrichment, sometimes 15 times higher, in bacteria known for their butyrate-producing skills. Studies looking at semi-supercentenarians, aged 105-109, further underscore the importance of specific beneficial microbes, showing higher levels of health allies like bifidobacteria and Akkermansia, which can make up 90% of the gut bacteria in healthy breastfed infants, typically plummet in adulthood, often falling below 5% and can dip even lower in the elderly. Yet centenarians frequently resist this decline. Then there's Akkermansia muciniphilae, the mucus lover, perfectly named because it thrives in the protective mucus layer lining our intestines. This vital shield unfortunately tends to thin with age, a process made worse by modern low-fiber diets that effectively starve many gut microbes. potentially forcing some to munch on the mucus layer itself. Seems unique. It appears to actually encourage our intestinal cells to produce more mucus, actively helping to rebuild and maintain this critical defense. So this it's still. The EA shows abundant in healthy older adults and centenarians, but scarce in frail individuals. Intriguingly, feeding Akkermansia to mice genetically programmed for rapid aging significantly extended their lives. This leads us to the million-dollar question: are these microbial changes causing aging, or just reflecting it? The truth is likely a complex dance. Aging itself fosters conditions perfect for dysbiosis, that unhealthy microbial imbalance. Changes in taste and smell, dental problems steering us away from fibrous foods, increased medication use, and incredibly, studies show about 24% of common non-antibiotic drugs can hinder gut bacteria growth. Plus less physical activity slowing things down in the gut, all weave together. Low-fiber diets, especially common in places like nursing homes, are a huge contributor. And while we often assume poor diet leads to dysbiosis, which leads to poor health, the influence flows both ways. Poor health impacts diet and medication use, creating vicious cycles. Even intriguing findings, like centenarian microbes being better detoxifiers of industrial pollutants, raise questions. Is this helping them live longer, or is it just an adaptation from decades of exposure? Diet remains a powerful constant. Remember those Bama centenarians? They ate over 70% more fiber per calorie than their younger regional peers. Some of the most persuasive evidence for a causal link comes from fecal microbiota transplantation, or FMT, experiments. Giving gut microbes from young animals to older ones has extended the recipient's health span and lifespan. One particularly vivid study transplanted human fecal matter into mice. Mice receiving microbes from a 101-year-old whose sample was rich in fiber-loving bacteria showed more youthful traits, including less age pigment buildup in their brains. This was a world away from mice getting feces from a 70-year-old whose sample had more pro-inflammatory bacteria. It's early days, but these results certainly spark imagination about future therapies. So how do we intentionally cultivate a gut environment that supports healthy aging? The answer keeps pointing back to one thing: focus on what you feed it. Not enough dietary fiber essentially starves our microbial friends. On the flip side, things like excessive antibiotic use, and estimates suggest a huge chunk, maybe 75%, of prescriptions might be unnecessary. High salt intake, too much protein, especially from animals, and certain food additives can seriously disrupt the delicate balance. We also face the daily, often invisible, intake of antibiotic residues in conventionally produced meat, dairy, and eggs. An astonishing amount, up to 80% of antibiotics used in the USA go to farm animals, often just to promote growth or prevent illness in crowded conditions. These residues can be enough to encourage resistant bacteria in our own gut, and resistance genes can jump between bacteria frighteningly fast. As a result, people following strictly plant-based diets carry significantly fewer of these resistance genes. This widespread dysbiosis is increasingly seen as a key accelerator of aging, largely by contributing to leaky gut and the resulting chronic low-level systemic inflammation, often called inflammaging. Inflammaging is a strong predictor not just of dying prematurely, but also of frailty, losing independence, and being more vulnerable to infections like pneumonia, a major killer of the very old. Dysbiosis. It directly weakens immune function, for instance, making our immune cells less effective hunters of bacteria. Remarkably, mice raised germ-free don't get leaky gut or inflammaging, and they keep their youthful immune power much longer. Preventing the dysbiosis that fuels inflammaging relies heavily on smart dietary choices and careful medical practices. Maximize your fiber intake. Minimize unnecessary antibiotics, both directly and through food choices. If antibiotics are needed, bolster your microbiome's resilience with a high-fiber, lower-sugar diet. Be wary of ultra-processed foods, usually fiber-poor and often loaded with disruptive additives like high salt, which depletes beneficial lactobacillus, and certain emulsifiers that can harm the mucus barrier. We also need to think about protein putrefaction. Often excess protein, particularly animal protein rich in sulfur-containing amino acids, hits the colon. Certain bacteria break it down, creating potentially toxic byproducts like ammonia and hydrogen sulfide, H2S, that rotten egg smell linked to gut inflammation. Meat consumption is a major predictor of fecal sulfide. Plant-based eaters produce dramatically less. One molecule brilliantly illustrates this intricate diet microbe disease web. Trimethylamine oxide, or TMAO, are gut bacteria. Make it mainly from precursors like choline, think eggs and carnitine, think meat. High blood levels of TMAO are strongly tied to significantly higher risks of heart attack and stroke, quadrupling stroke death risk, and premature death from all causes. Crucially, these links seem independent of traditional risk factors like cholesterol. Mechanistically, TMAO fuels atherosclerosis, makes blood platelets stickier, raising clot risk, and harms blood vessel function. Beyond heart disease, it's connected to a disturbing list of other conditions: kidney failure, dementia, diabetes, PCOS, several cancers, contributing to 8 of the top 10 causes of death. Eating eggs or meat triggers a rapid TMAO spike. But people on long-term vegan diets produce very little TMAO even after eating steak, likely because their microbiome lacks the right bacterial tools. Encouragingly, swapping just 2 daily servings of meat for plant-based options can lower TMAO levels within weeks. Interestingly, plant foods also rich in choline, like Brussels sprouts, don't typically raise TMAO. The most effective strategy: limit animal products, preventing the TMAO-producing bacteria from flourishing. Maybe TMAO really should stand for time to minimize intake of animal products. With all this growing awareness, what about the multi-billion-dollar probiotic supplement industry? Despite the hype, health claims often run ahead of solid science. Independent analyses show promotional websites are frequently unreliable, and systematic reviews find insufficient evidence to recommend probiotics for general health in healthy older adults. Quality control is another big issue, with frequent mislabeling, wrong bugs, wrong amounts, and contamination with unlisted microbes or even mold. Fundamentally, even if a supplement has the right stuff, the bacteria usually don't stick around unless significant dietary changes create a welcoming home. They're often a temporary fix if the underlying diet, the microbiome's fuel, stays the same. Fermented foods also show mixed results in studies. In sharp contrast, the benefits of prebiotics are much more consistently backed by evidence. Prebiotics are essentially food ingredients, mostly diverse types of dietary fiber and resistant starch, found generously in legumes and also formed when starchy foods like potatoes or rice are cooked and cooled, that selectively feed beneficial gut bacteria like Bifidobacterius and Lactobacillus. Meta-analyses confirm prebiotic consumption reliably boosts these good guys. These microbes then use prebiotics to create beneficial metabolic byproducts called postbiotics, most notably those SCFAs like butyrate and acetate, which have wide-ranging positive effects. Polyphenols, the vibrant compounds in fruits, vegetables, tea, coffee, and dark chocolate, also act as important prebiotics, encouraging beneficial bacteria. Plus, our gut microbes transform these polyphenols into other powerful postbiotics, like urolithins, derived from L-gitannins in berries and walnuts, which show exciting potential for improving mitochondrial function and muscle health, effects similar to exercise. But benefiting requires having the right microbes. Vegetarians tend to have more urolithin producers. Beyond the microbiome, broader dietary approaches profoundly shape aging. Caloric restriction, CR, without malnutrition is one of the most powerful interventions known to extend health span and lifespan across many species. The CALERIE trial, the most rigorous human study, found that even mild CR, about 12% fewer calories, improved quality of life, mood, sleep, significantly slashed dangerous belly fat, boosted metabolic markers like blood pressure and insulin sensitivity, and seemed to slow biological aging. Crucially, diet quality also generally improved, making it tricky to isolate CRS effects. Combining any CR with exercise, especially resistance training, is vital for keeping muscle and bone strong. Intermittent fasting IF strategies are popular alternatives. While some forms have mixed results, time-restricted eating TRE, especially shifting the eating window earlier in the day, like 8 a.m. to 3 p.m., shows consistent promise. This early TRE delivers significant metabolic wins, including impressive blood pressure drops and better insulin sensitivity, even without cutting total calories. Intriguingly, a growing wave of evidence suggests much of the benefit once credited solely to CR might actually come from protein restriction PR, specifically cutting back on animal protein. Protein intake strongly influences the growth hormone IGF-1, linked to faster aging. Plant-based diets naturally lead to lower IGF-1 levels. Conversely, restricting protein, especially from sources low in the amino acid methionine, ramps up the longevity-promoting hormone FGF21, something also seen clearly in plant-based eaters. Landmark mouse studies found the longest lives occurred on diets with the lowest protein-to-carbohydrate ratios, about 1 part protein to 10 parts complex carbs, regardless of total calories. This ratio uncannily matches the traditional Okinawan diet, famous for longevity. In large human studies, the pattern is consistent. More animal protein intake correlates with higher death rates, while more plant protein intake correlates with lower death rates. Swapping even tiny amounts, just 3% of daily calories, from animal to plant protein is linked to a significantly lower risk of death. Specific amino acids seem key. Methionine and branched-chain amino acids, BCAAs, both concentrated in animal protein but lower in plants, are strongly implicated in aging and metabolic problems like insulin resistance. Cutting back on these, easily done by shifting to plant-based protein, appears highly beneficial. The cumulative evidence strongly points towards reducing total protein intake towards recommended levels, around 0.8 grams per kilogram of ideal body weight, and emphasizing protein sourced mainly from plants. And what about NAD+, the molecule creating such an anti-aging buzz? NAD+ is absolutely vital for cell energy and enzyme function, but claims that levels inevitably drop with age and that precursor supplements, like NR or NMN, are the solution rest on shaky human evidence. While these supplements work wonders in rodents, they've largely failed to show significant clinical benefits in human trials, often not even boosting NAD+ levels effectively in human muscle. Plus, the supplement market struggles with quality control, and long-term safety isn't proven. In contrast, natural methods seem far better at boosting NAD+ in humans. Exercise, especially resistance training, dramatically increases NAD+ levels and synthesis enzymes in muscle, something supplements haven't matched. Also, strategies to reduce NAD+ breakdown, like minimizing DNA damage with antioxidants and reducing chronic inflammaging, offer a more physiological approach. While we continue decoding these complex molecular pathways, let's not forget the immense power of foundational healthy habits. Simply combining 4 key factors: eating a healthy diet, getting regular physical activity, maintaining a healthy weight, and avoiding smoking, can add more than a decade to average lifespan. And these benefits kick in even if you start later in life. Among these, diet consistently stands out as the single most potent tool we have to influence the aging process, acting as the #1 determinant of our longevity and chronic disease risk. Despite this potential, dietary habits in many places are sadly worsening, yet there's remarkable global agreement among top health experts. The optimal diet for human health and longevity is one built predominantly around minimally processed whole plant foods. This aligns beautifully with our evolutionary past, mirrors the diets of the world's longest-lived populations, and is the only dietary approach rigorously proven in randomized controlled trials to halt and even reverse coronary artery disease, a leading killer. So our journey into understanding aging inevitably leads us inward, to the trillions of microbial partners sharing our existence. Learning about and nurturing this internal ecosystem through our daily food choices, prioritizing a rich variety of fiber-packed whole plant foods like fruits, vegetables, whole grains, and especially legumes, isn't just some niche health trend. It's emerging as perhaps the most powerful, accessible, and sustainable strategy we possess to influence not just how long we live, but how vibrantly and healthily we navigate all our years. Ultimately, feeding ourselves means feeding them too, and choosing to feed them well might just be the smartest investment we can make in our own long, healthy, and fulfilling future.